Hello, welcome to RCC's Math Tape 064 Exponential Expressions. On this tape we will multiply, divide, and raise to power exponential expressions. You are expected to know already what an exponent means, what its base is, how much the exponent affects. If you need to review this material, ask for help from the lab instructor or tutor to decide what tapes you need to look at. As we go through the tape, take thorough and careful notes. Mark on your paper any place you don't understand so that you can get help from the lab instructor or tutor when you go to the lab. Also, if you miss any of the problems I give you for exercises, be sure to mark those so you can get help as you need it. Now let's begin. The objective on this tape is to simplify exponential expressions. Simplify exponential expressions. You should recall what an exponent means. For instance, you should recall that x with an exponent 4 means that x is multiplied by itself 4 times. The exponent 4 tells us how many times to use the base x as a factor. This leads to a very simple procedure for simplifying exponential expressions. This procedure is very important. I've put a star beside it. Be sure you write it down as we go so that you'll be able to use it in working the problems. The procedure to simplify an exponential expression. To simplify an exponential expression, step 1, write the expression in factored form. Write the expression in factored form. Step 2, simplify the result. Simplify the result. Step 3, write the answer in exponential form. Write the answer in exponential form. So our 3 steps are to write the expression in factored form. Write the factors spread out. Then simplify the result. This may involve multiplying. It may involve simply counting factors. Finally, write the answer in exponential form. Let's look at examples. Our examples all have as their instructions, simplify. Example 1, negative 9x to the third power in parentheses. In another set of parentheses beside it, 4x to the second power. So we have negative 9x cubed times 4x squared. Step 1 is to write this expression in factored form. Factors are things that are multiplied, so we're to write out what is being multiplied. Let's group together the coefficients, negative 9 and 4. So we begin with negative 9 times 4. Then x to the power 3, the power 3 tells us to use x as a factor 3 times, and so we write x. X to the power 2 from the other set of parentheses tells us to use x as a factor twice, and so we write x. So this gives us negative 9 times 4 times in parentheses x times x. Now we multiply the negative 9 times 4 to get negative 36. X times XX means we're using x as a factor 5 times, writing that in exponential form gives us negative 36 x to the power 5. Negative 36 x to the power 5 as our final answer. Notice that in simplifying this expression, we put the coefficients together. The coefficients needed to be multiplied together. And then the powers of the variables were strung out. X to the power 3 gave us a string of 3 x's. X to the power 2 gave us a string of 2 x's. Then putting all of that together, we had x to the power 5. Let's do another example. Our next example is, in parentheses, negative 2 y to the third power, close parentheses, exponent 2. So we have the expression negative 2yz to the third raised to the power 2. Negative 2yz to the third raised to the power 2. Now, we have a choice. We could either work inside the parentheses, as we customarily do, or we can let the exponent outside tell us to use this entire base as a factor twice. Let's take the big picture and use the exponent 2 to tell us to write this entire expression twice. So we'll write, in parentheses, negative 2yz to the third times another set of parentheses with negative 2yz to the third. Notice that now this is very much like the one we've already worked. We have coefficients of negative 2 and negative 2. They will be grouped together. We have a variable y from the first parentheses and another variable y from the second parentheses. They are grouped together. Then we have the variable z with the exponent 3, which means a string of 3 z's from the first parentheses. And finally, from the last parentheses, another string of 3 z's. The simplifying is simply a matter of rearranging to group together the coefficients, the y factors, and the z factors. Now to finish, we do the indicated multiplication. Negative 2 times negative 2 is positive 4. Y is used twice, so we have y with the exponent 2. Z is used 6 times, and so we have exponent 6 on the z. So our final answer is 4y squared z to the 6th. 4y squared z to the 6th. For example 3, let's use one that involves a fraction. For this one we have, in parentheses, 1/2 x to the power 2, close the parentheses, exponent 3. In the next set of parentheses, 4x to the power 3. Again, let's take the big picture and let this exponent 3 outside the parentheses tell us to write that expression 3 times. And so we get 1/2 x squared times 1/2 x squared times 1/2 x squared times 4x to the third. Grouping the coefficients together, we'll put together the 1/2 times 1/2 times 1/2 times 4. I'm writing the 4 as 4 over 1 because we have fractions, and writing the last factor in fraction form will make it easier to keep up with. The variables, x squared from the first one, so that's a pair of x's. X squared from the next one, another pair of x's. X squared from the third one, another pair of x's. And x to the third power from the last one, so a string of 3 x's.